there are lots of different measures of dispersion. The simpler ones, the range is just the distance between the biggest observation and the smallest observation. So the person with the highest income and the lowest income, what's that distance? So that gives you a bit of a measure of spread. But like the mean, it's going to be vulnerable to outliers. So that number will get bigger if there are a small number of people with really large incomes that are right far up the distribution, and it doesn't tell you much about the middle. Percentiles. That's looking at different points in the distribution. So remember, if we lined up everybody in their income, the median was the person in the middle. But we might want to say, well, okay, what about the person that's a quarter of the way through? So at 25%. So where there's a quarter earning less than them and 3/4 earning more. And we might want to compare their income to the person that's in the equivalent point on the other side at the 75th percentile, where a quarter of people are earning more and 3/4 are earning less, and look at that difference. So rather than just looking at the difference between the ends, look at the difference between those 2 points. And obviously we could pick any 2 points in the distribution, depending on where we think the action is, if you like. But we can get some sense of the spread by comparing different points. So lining everybody up and then looking at the difference between people at different points in that line. The standard deviation, which we just talked about, gives us this standard measure that takes into account all of the data and gives us some sense of that spread. There are other measures which I'm not going to go into in detail, but depending on your application, you may want to explore further yourself. Kurtosis and skewness, which are basically measures looking at how far the distribution of income, say, differs from a normal distribution, from that bell curve that we saw in the introductory lecture. So income differs quite a lot from that because there's a mass of people at the lower end and then a long tail. Okay, so that doesn't look very much like a bell curve. So there are some measures that will give you a number estimating how different a distribution is from that normal curve. And then rankings, so categorical ordering of metric data that can give you some sense of which values are where and how spread out they are. The one you're going to use most often, though, is the standard deviation in the middle here, although it can be useful to look at some of the simpler and some of the more complicated measures, particularly if your data is doing something strange, if it doesn't have a sort of standard shape, and you want to understand what that shape is. Okay. So this is just an example of some of the output that you'll see. You don't need to worry too much about the detail here, because when you run the practicals, you'll be generating these tables and graphs yourself, so you'll get to look at them in detail in the practical exercise. But if you use the software to summarize, this is working hours for men up here, for women down here. You're going to get a table that's going to tell you how many people there are in the data set. So there's 1,375 men. That's going to tell you, well, the 50th percentile. That's the median. So if we line everybody up by how many hours they work, the median is actually 40 hours per week. It's going to tell you the largest and the smallest. It's going to tell you the mean, so the average number of hours is 42. So there's a little bit, already we're thinking there's maybe a little bit of skewing there, because the average number of hours, the mean number of hours at 42 is slightly above the median. So perhaps there's some outliers. It's giving you a standard deviation of 14 hours. And you can see the graph over here that is graphing this data here. So, and that matches up pretty well. There's a big mass around 40 hours here. A lot of people around. That's not too surprising. But then there is more people above 40 hours than there is below. So this isn't a perfect bell curve. There is a bit of skewing here, which that difference between the mean and the median was suggesting that the average was being pulled higher by there being a number of people with higher hours. right up to the maximum. Okay. Now, one interesting thing from here is that if you look at the 75th percentile, so that's the person where a quarter of people are working more hours than them and 3/4 are working less. It's 45, 60, 70, 90. We've got the largest value here is 97. So just flag that up, because a lot of this sort of data is going to be censored right at the top end, and typically at 97. So when you see these values repeated, that's often a warning that the data is censored, that there might be people who said they've worked more hours than that, but once you get into really small numbers of people, you start to worry about it being possible to identify in individuals. So variables like this, and for example, age will often be censored in the data at a value around there, because there's going to be, there will be small numbers of people that are aged over 100, but there is a risk that age, and there being a small number of people with that age, starts to make people identifiable. So you have to be aware that at the top end here, some of these people where 97 is recorded might actually be working more hours, but they've been collapsed together. Okay. And then it's possible in the software, this is summarizing work hours. It was done separately there for male and female workers to restrict that further. So in the exercise, you'll be looking at, for an example here, restricting it to people aged between 30 and 40, and again by male and female. So you can start pulling out subsamples of the data and looking at their characteristics. And making a comparison. So here we might be comparing the working hour patterns for men and women, but we can also do that for different subsamples of age. So when we have a good amount of data, and there was thousands of observations there, we have nearly 400 men and 362 women aged between 30 and 40 in the data set, we can start exploring more complicated patterns.